So, good day everyone. Today we will be discussing geotechnical engineering presented to you by San Mark Vincent, Gaboyo Wilperdi, Daniel G, and Jimenez Pabies. And so, what is geotechnical engineering? Geotechnical engineering is the study of behavior of soil under the influence of loading forces and soil-water interaction. This knowledge is applied to design a foundation, retaining walls, earth dams, clay liners, geosynthetic for waste containment. And the goals of geotechnical engineers could range from design of foundation and temporary excavation support, to route selection for railways and highways, to increase the important area of landfill disposal of waste and groundwater contamination. The geotechnical engineer is involved in field and laboratory investigation to determine the engineering properties of site soils and other geomaterial, and their subsequent use in analytical study of problem at hand. So now, let's take a little trip to history. The science of geotechnical engineering was primarily developed by Austrian Karl Tergasi in earlier 20th century. He was professor at Vienna University of Technology and later at Harvard University. Before his death in 1960, he quit all his technical and scientific material to NGI. His works are held by Tergasi Library at NGI, which opened in 1967. So, now, what are the applications of geotechnical engineering? Where is this applied? Like I said earlier, geotechnical engineering is the study of behavior of soil under the influence of loading forces and soil-water interaction. Geotechnical engineering could range from design of foundation and temporary excavation support. Geotechnical engineering is involved in field and laboratory investigation to determine the engineering properties of site and soil and other geomaterials, such as it can be applied in foundation, retaining walls, earth dams, and concrete dams.
Soil mechanics and rock mechanics. Geotechnical engineering uses the principles of soil mechanics and rock mechanics to investigate subsurface conditions and materials, determine the relevant physical, mechanical, and chemical properties of this material, evaluate stability of natural slopes and man-made soils deposit, assess risks posed by site condition, design earthworks and structure foundation, and monitor site condition, earthwork, and foundation construction. Soil. The term soil has different meanings in different scientific fields. It has originated from the Latin word solum. To an agricultural scientist, it means the loose material on the Earth's crust consisting of disintegrated rock with an admixture of organic matter which support plants' life. To a geologist, it means disintegrated rock material which has not been transported from the place of origin. Mechanics. Rock mechanics is the study of mechanical behavior or subsurface sedimentary strata and rocks that are formed. The basic principle is that the rock simply responds to stress by changing in volume or form. Research and development in geotechnical engineering. Research and development in geotechnical engineering is carried out to improve and further refine equipment and methods for carrying out ground surveys. Equipment and methods for surveying and testing sediment and rock sample in a laboratory. Methods for calculating and analysis the behavior and varying capacity of soil and rocks when planning structures, offshore installation, tunnels, and subterranean spaces. Methods for measuring, instrumenting, and subsequently documenting whether buildings and other structures behave the way they were designed to. Geotechnical engineering deals with design of roads, design of functions, stability of slopes and cuts, design of earth structures and airfields. The study of the geological materials properties on a construction site are important to allow design and construction of stable structures and structures that do not settle deform or crack, and do not fall down due to foundation failure.
So I'm back, and here we are to the absence of geotechnical engineering. So, so without geotechnical engineering, the risk of collapses rises. For instance, consider building in an area close to waterways. There's a lot of sediments there, so it's not rock, it's not sand, just a big heap of sediments. If something is built on that, slowly will become more and more heavy, and the building will eventually sink. Geotechnical engineering can prevent such a catastrophe by investigating and making calculation about the soil beforehand. Through investigation, they can find out whether there is sand, rock, chip, or anything else inside. When you know that, you know which layers can carry the building or the bridge. That's what the technical engineering does. If we don't carry out this kind of investigation analysis, sometimes it will be okay, but in a lot of cases, the building will collapse. Mm. And so, conclusion. Geotechnical engineering is a subdiscipline of civil engineering and can be defined as the use of earth materials, soil and rock, soil and rock for improving depending society and life. Until about the last 100 years, geotechnical engineering was largely empirical and based on observation and careful reflection. Geotechnical engineering is a critical component of nearly infrastructure related endeavors, whether they be a civilian or military. This is because every except space structure such as satellite is founded in Earth. Furthermore, if there are issues with the foundation, then the entire structure is in trouble. Therefore, geotechnical engineering plays a critical role in every constructed project. Geotechnical engineering relies on the continuous application of engineering judgment. This judgment can be the best development by careful study of past success and failures and years of experience. Through continued education, the mentorship and experience are passed from one generation to the next, leading to continued advancement of the profession. Geotechnical engineers investigate and evaluate soil, rock, groundwater, and man-made materials, and their interaction with earth retention system, structure foundation, and other civil engineer works. They perform detailed soil investigation which are required before building any structure to avoid foundation failure. The result of this investigation are used to determine the nature and capacity of the soil to support a stable foundation. Geotechnical engineer must learn and understand ground hazard and risk and be able to be practical solution to this issue. So guys, that's it. Thank you for listening.